Okay, I managed to not clean up my disk and it ran out of space, big disk, but so be it. So I had just a little bit more to say here. Again, not sure exactly where I ended up, but it should be clear that what we have here is a right triangle. Since we have a right angle here, of course we have a right angle in here. And V being opposite, theta being the angle between V and W. The length of the projection, the magnitude of the projection, has to be equal to the length or magnitude of V multiplied by the cosine of theta, or at least multiplied by the absolute value of the cosine of theta. So that's what I've said here. The magnitude of this projection vector, projection onto W of V, is equal to the magnitude of V times the absolute value of the cosine of theta. Now, why do I say absolute value of cosine theta? Well, it's because there's no reason that theta has to be less than 90 degrees. V could be out in this direction and W back here, in which case theta would be greater than 90 degrees and the cosine of theta would then be negative. So we have to have the absolute value sign around that if we want to talk about the length or magnitude of this projection vector. Now, as it turns out, the fact that the cosine can become negative takes care of the case where this angle is greater than 90 degrees, so that you have a projection that's in the direction opposite W. In this case, the projection is in the direction of W, and it has to be along the line of W, but it doesn't necessarily have to be in the same direction. It could be in the direction opposite W along the same line.